Guys, today we're going to be talking about wireless networks and we're going to be starting with some theoretical knowledge. Let's go ahead and start with description of wireless network. What it is, when it was first created and how we can utilize it to work for us, at the same time how we can hack it. Let's go forward, guys. So a wireless network is a set of two or more devices which are connected in themselves via radio waves within a limited range. That means that the devices in a wireless network have the freedom to be connected without any additional wires. There might be a case where the devices are not close to one another, or maybe there is no option for wiring the space or the open area that they are in, and that also poses a great danger for the security of the network, since remote attacker could mess with the radio signals from a distance without even being close or within that network range. Attackers might use powerful antennas to get to the specific network, connect to it, sniff some traffic, brute force the password, and even intercept weakly encrypted communication. So let's move forward and look at the history of wireless networks. Wireless networks are widely used, and it is quite easy to configure them and set them up. They usually use IEEE 802.11 standards. A wireless router is the most important device within a wireless network because through the router all different users connect to the internet. Let's look at the history of wireless networks. The first professional wireless network was developed under the brand Aloha Net in 1969 at the University of Hawaii, and actually became operational in June 1971. Wow, that's amazing. That's quite a bit of story here, starting like almost 60, 50 something years ago. That's a lot. Moving forward, we can say that the first commercial wireless network was the Waveland product family, developed by NCR in 1986. So of course, first it was developed just for internal use. Some some students at the University of Hawaii developed this to serve their needs. Maybe to it was a project, an idea that they wanted to prove, or a project that was related to enhancing, improving the overall communication within the university. But then, shortly after that, it became a wide and really popular thing, since the need of the commerce and actually all the different corporations, small businesses, and the need of having this easy to use and easy to access, easy to set up network brought up this the creation of that commercial product. And it's really important that uh, to say that almost all businesses these days are using Wi-Fi networks. All the different households, they usually use Wi-Fi networks, since you want to be able to connect whenever and wherever you are within your house, apartment, maybe a gym or something. So we're all using those, and they're all available throughout the city, even in some remote areas. Internet is becoming really, really um, open and available for everyone, no matter where they live and how they want to access it. But here comes the danger. The problem grows, and it has security um, related issues. Once people are connecting to random networks and they actually save their settings on their mobile devices, computers, so whenever the device sees the same SSID, which will be the name of the specific network, it will connect to it right away automatically. Most of the devices are set that way. So here comes the danger without actually knowing what encryption and who's behind that access point and what encryption is using. We might be in grave danger once we try to access our banking account online, maybe go and log into some websites using SSL and encrypted communication will be a good way to go about it, but keep in mind that there is also the SSL strip attack, which will take care of the SSL communication, look at everything in plain text of our communication, which might be really, really harmful for our personal information. So now let's move forward and see the different types of wireless networks and how they work. Let's move on to types of wireless networks. First one we're looking at is the wireless PAN. So it will be spelled like PAN. Wireless Personal Area Networks, which stands as WPAN acronym, usually is used for connecting relatively small area devices within that small area. It is generally within a person's reach. Let's go with example here. We're talking about Bluetooth radio, invisible infrared light provided a WPAN for interconnecting um, headset to laptop, for example, or headset to a mobile device, let's say a smartphone. Examples for such wireless PAN networks will be the Zigbee supporting WPAN application. Wi-Fi PANs are becoming really, really widely used, and we can see Intel My Wi-Fi as a good example, and Windows 7 Virtual Wi-Fi. Also, Wi-Fi PANs are really simpler and easy to configure and set up. In general, that technology and this type of wireless network serves greatly to the humanity by just connecting devices within really, really short distance, but just enough so it will bring convenience to the user, and it will ease up a lot of the processes of dealing with wires, maybe changing some adapters, whatever it is. That type of communication and the use of good um, connectors on both sides will bring great functionality and convenience to the user. Moving forward, we're looking at wireless LAN. So it will be spelled LAN. A wireless local area network, WLAN, links two or more devices over a relatively short distance using a wireless distribution method. Usually, uh, it's related to providing a connection through an access point for internet access to the World Wide Web. The use of spread spectrum or OFDM technologies may also allow each user to circle around within a local coverage area. So we're talking about medium distance here, maybe a few feet away, and depending on the router here and the antenna and the coverage of that router, it could go a little broader than that. Products using the IEEE 802.11 WAN standard are marketed under the Wi-Fi brand name. The fixed wireless technology implements point-to-point links between different devices or networks at two or more distant locations, often using dedicated microwave or modulated laser light beams over a line of sight paths. It is really used often in different cities to connect various networks in two or more buildings without installing a wired link. Um, Definitely to connect Wi-Fi, sometimes are use devices like router or connecting hotspot. Maybe using smartphones as you often use your hotspot to maybe provide your laptop or your friend's laptop or friend's device with internet connection. So you're turning your smart device, let's say smartphone, to an access point. That means that all the traffic that the other device connected to your access point generates, all that traffic will be monitored, and there is a way to actually monitor each request going to a specific server, web page, whatever it is. You can monitor that, and you can actually sniff the traffic. You can play with the requests and packets going back and forth. You can actually make a lot of harm to a person connected to your access point, and that means that it's not safe to just connect to random access points, even though the name sounds familiar, since the name of the access point could be changed easily and you can set up whatever name you like. That makes things really tricky, so keep in mind to trust only networks that you know and you're certain about. Password protect those networks with really complex passwords using all the needed uppercase, number, special character, lowercase, and use, I would say, 10 or more symbols. I usually shoot for 12 and more or more, and go with passphrases. In my opinion, that's really the right way to go. Also, the encryption that you use on your wireless network is really important. Using the most up-to-date encryption algorithm will ensure that it's not easy, or at least it's not that easy, to break into your wireless network or sniff traffic, decrypt some of the communications, and etc. etc. Moving forward, we will look at wireless ad hoc network. A wireless ad hoc network, also known as a mesh network or mobile ad hoc network, is a wireless network created out of radio nodes organized in a mixed topology, um, mesh topology also used. So each node forwards the message on behalf of other nodes, so they're kind of interconnected to one another, and it's really easy to adapt. Once one of the nodes loses power, they automatically reroute the traffic through another node which will be available at the moment. That's really valuable for the availability of that network. Various network layer protocols are needed to realize ad hoc mobile networks. Such protocols will be the distance sequence distance vector, and also ad hoc on-demand distance vector routing and dynamic source routing. Another one will be the associativity based routing. This is just informational for you to know. Moving forward, we'll go to the next one, which will be the wireless MAN network. The wireless MAN network stands for Wireless Metropolitan Area Networks. Those are type of wireless networks that actually connect several wireless LANs. A good example of such wireless network will be the WiMAX, and it's actually described by the IEEE 802.16 standard. You can read about this standard by yourself. Uh, it's a really good implementation of wireless networks, since it will help us connect different LANs together, and this is usually used by the huge um, telecommunication companies, internet providers. It's really we're talking about covering a whole city, let's say. So think think about the resource that you need to do that. It's really amazing, but it's really at the same time really helpful for users to use the availability and the convenience of such network. Now we are moving to the wireless WAN. So we're talking about WAN, wireless wide area networks. This type of wireless network typically typically used to cover large areas, such as between neighboring cities, maybe um, suburban areas and the city, or maybe we're talking about different branch offices of a specific business, or maybe as public internet access system. We're talking about really long radio waves here. The wireless connections between access points are usually point to point, and they're using microwave links, uh, which utilize parabolic dishes on the 2.4 gigahertz and the 5.8 gigahertz band, rather than omnidirectional antennas used with smaller and really limited networks. A typical system contains gateways, access points, and wireless bridging relays. These are the three main components of such wireless network. Other configurations also include mesh systems where each access point actually uh, act as a relay also. When combined with renewable energy, for example, such as photovoltaic solar panels or maybe wind systems, they can be definitely used as standalone systems. Next, we move to cellular network. A cellular network or mobile network is a radio network which are called cells. Each cell is served by at least one fixed location, which is called transceiver, known as a cell site or base station. In such cellular network, each cell characterize, um, characterizes itself with different set of radio frequencies from all immediate neighboring cells to avoid any interference. So we're talking about different frequency for each cell. So we are avoiding interference here. We are avoiding the actually dropping or maybe unavailability of a specific cell. That's why they use different bands. In this case, frequencies, radio frequencies. When joined together, those cells provide radio coverage over really, really wide geographical areas. As you know, those cellular networks can cover the entire US, for example, or the entire North American continent. So here we're talking about really wide, enormous areas, and that's why engineers came up with such architecture of a wireless network. This enables a large number of portable transceivers. An example for transceiver will be mobile phone, smartphone, and maybe if someone still uses pager, etc., to communicate with each other. And with fixed transceivers and telephones anywhere in that specific network via base stations. Even if number of those transceivers are actually moving around through more than one cell during the transmission. What does it mean? That means that no matter how you are actually moving around with your transceiver, let's say mobile device that has the SIM card with enable mobile data, it will actually be available for all the other devices, and different transceivers within that wide area can keep the communication going no matter how they move dynamically around. That brings the convenience that once you are driving from downtown to suburban area where your house is, for example, and you're talking with your wife on the phone while you're driving, you're moving and changing different cells, but that does not bother your communication and your conversation in this case. So this uh, type of wireless network really brings the great and enormous, let's say, outstanding value, since it lets people communicate with each other um, continuously while moving around wide areas. So maybe you're flying out somewhere, maybe you're driving, maybe you're just on a bus to somewhere, train, stuff like that. Whenever you have the coverage, you can communicate with other people within that same or maybe other interconnected cellular networks. So that's really convenient and amazing. We are all using that functionality on daily basis, and that's really helpful these days. Cool guys, moving forward at Global Area Network, or also known as GAN. GAN. This type of wireless network is widely used for supporting mobile across arbitrary number of wireless LANs, satellite coverage areas, or something similar. The key challenge in mobile communications is handling of user communication from one local coverage area to the next. So in the IEEE project 802, this involves a succession of terrestrial wireless LANs. So here definitely we are fighting a huge um, challenge to the engineering world and handling communications um, from one local coverage area to the next and keeping everything smooth without breaking up signal, without closing current communication between devices, and that definitely brings value. The last one that we're going to be looking at, the last network, will be the space wireless network type. This is definitely, from its title, you can see that it's used for communication between spacecrafts, usually in the vicinity of the Mother Earth. The example of such network is NASA's space network. So you can see that this type of communication started from a university in Hawaii in 1969, and these days it's used everywhere. And definitely that brings some thoughts, and you can think of other ways and other areas of your everyday life that you see and you use such wireless networks. The um, simplicity and actually the convenience of such networks brings um, the genius mind that stays behind the creation of such network. And I can definitely say that hacking on wireless networks is really a lot of fun. From my experience, that takes a lot of knowledge on different wireless protocols, how everything is set up, how the router works, and what type of routers are utilized, how you can actually break up a communication between active communication between a device and access point and trick that device to connect again, but to your access point. So DAuth, DAuth, sending DAuth packets, and so on and so forth. A lot of cool stuff that we're going to be looking at moving forward in this course. Now let's look at the IEEE 802 family. Since we've been talking a lot about this in the last few sections, now let's say a few more words and deep dive into the IEEE 802 family. It's actually family of standards dealing with local area networks and metropolitan area networks. So we're talking about LAN and MAN networks. More specifically, the IEEE 802 standards are limited to networks carrying variable size packets. By contrast, in a cell relay network, data is usually transferred in short, uniform, precise size units called cells. Isochronous networks, where data is transmitted as a steady stream of octets, or actually groups of octets, or this is a second option, so it could be either just stream of octets or different groups at regular time intervals are also out of the scope for this standard. The number 802 was simply the next available one that IEEE could assign. Though 802 is sometimes associated also with the date the first meeting was held, and that was in February 1980. The services and protocols specified in the IEEE 802 map to the lower two layers. We're talking about data link and the physical layer of the 7-layer OSI network model. In fact, here we're talking about IEEE 802 splits. It actually splits the OSI data link layer into two sublayers named logical link control, which is also named LLC, and the media access control called MAC. So the layers can be listed like this. We have the general data link layer, and we have the two sublayers here, the LLC and the MAC, and then we go to physical layer. Here you can actually review the OSI model, since this is really something fundamental for networking in general, and in this case it helps us understand how the wireless networks and protocol standards and all that works. The IEEE 802 family of standards is generally maintained, supported by the IEEE 802 LAN Man Standard Committee. You can see the acronym as LMSC. The IEEE 802 family of standards is maintained and supported by the IEEE 802 Landman Standards Committee, which is also named LMSC. The most widely used standard are for the Ethernet family, wireless LAN, bridging, virtual bridged LANs, and token rings. An individual working group provides the focus for each of those areas, which is actually pretty cool since we really need a lot of smart heads banging uh, to the wall and actually brainstorming, trying to find better solutions for the humanity and for all users so we can benefit, so we can all benefit from it. Thanks, guys. Now we move forward to the next section.